Neutron stars are the densest things that are not black holes. In their cores, we might find the most dangerous substance in existence: strange matter, a bizarre thing so extreme that it bends the rules of the universe and could infect and destroy everything it comes into contact with. Or it could teach us about how the universe began. Maybe both. To understand how extreme strange matter really is, we first need to get a few basics. What is a neutron star, and how does strange matter break the rules of the universe? To get all of this into one video, we'll grossly oversimplify a few things, but we'll provide you with further reading if you want more details. A neutron star is what remains after a very massive star explodes in a supernova. When this happens, the star's core collapses under its own gravity with such a strong inward force that it squeezes nuclei and particles together violently. Electrons are pushed into protons, so they merge and turn into neutrons. All the nothing inside of atoms is suddenly completely filled with particles that really don't want to be close to each other but have no choice. They desperately push back against gravity, against the collapse. If gravity wins, they will become a black hole. If they win, they become a neutron star. This makes neutron stars like giant atomic nuclei the size of a city, but holding the mass of our Sun. And here, things get weird. The environment in the core of neutron stars is so extreme that the rules of nuclear physics change. And this could lead to a strange and extremely dangerous substance. But let's not get ahead of ourselves. We first need to know the rules before we learn how they can be broken. Protons and neutrons, the particles making up the nuclei of atoms, are made up of smaller particles called quarks. Quarks really don't want to be alone. They are what we call confined. You can try to separate them, but the harder you pull, the harder they try to pull themselves back together. If you use a lot of energy, they just use this energy to create new quarks. Quarks only exist together as the building blocks of other particles and have never been observed by themselves. They come in many types, but only two appear to make stable matter: the up and down quarks found in protons and neutrons. All other quarks seem to decay away quickly. But this may be different inside neutron stars. The forces operating in their cores are so extreme that they are actually similar to the universe shortly after the Big Bang. Neutron star cores are like fossils, which can let us peer back in time to the beginning of everything. So learning how quarks behave inside a neutron star is a way of understanding the very nature of the universe itself. One hypothesis is that inside a neutron star core, protons and neutrons deconfine. All the particles crammed shoulder to shoulder dissolve and melt into a sort of bath of quarks. Uncountable numbers of particles become one giant thing made purely from quarks: quark matter. A star made from this is called a quark star, though from the outside it may not look any different than a regular neutron star. Now we can finally talk about the most dangerous substance. If the pressure inside a quark star is great enough, it may get stranger. Literally. In the cores of neutron stars, some of the quarks may be converted into strange quarks. Strange quarks have bizarre nuclear properties, and they are heavier and, for the lack of a better word, stronger. If they turn up, they could create strange matter. Strange matter might be the ideal state of matter: perfectly dense, perfectly stable, indestructible. More stable than any other matter in the universe. So stable that it can exist outside neutron stars. If this is the case, we have a problem. It might be infectious. Every piece of matter it touches might be so impressed by its stability that it would immediately turn it into strange matter too. Protons and neutrons would dissolve and become part of the quark bath, which frees energy and creates more strange matter. The only way to get rid of it would be to throw it into a black hole. But then again, who cares? All of it is inside neutron stars. Except when neutron stars collide with other neutron stars, or black holes, they spew out tremendous amounts of their insides, some of which could include little droplets of strange matter called strangelets. Strangelets are as dense as the core of a neutron star. They could be really small, maybe even subatomic, but even the largest strangelets wouldn't be any bigger than a rocket. These strangelets would drift through the galaxy for millions or billions of years until they meet a star or planet by chance. If one were to strike Earth, it would immediately start converting it into strange matter. The more it converts, the more it would grow. Ultimately, all of the atoms making up Earth would be converted. Earth would become a hot clump of strange matter the size of an asteroid. If a strangelet strikes the Sun, it would collapse into a strange star, eating through it like fire through a dry forest. This would not change the Sun's mass much, but it would become way less bright, so Earth would freeze to death. And like a tiny virus, we'd have no way to see a strangelet coming. Worse still, some theories suggest strangelets are more than common, outnumbering all stars in the galaxy. These strangelets could have formed very early after the Big Bang, when it was as hot and dense as a neutron star core everywhere. They might be clumping around the gravity of galaxies as the universe expanded and evolved. Strangelets could even be so numerous and massive that they might actually be the dark matter we suspect holds galaxies together. But then again, maybe not. This is speculation, and the Earth and Sun and planets haven't been consumed in a wildfire of strangelets in the past few billion years, so the odds seem good that it won't happen anytime soon. Understanding these strange objects today may be the key to understanding the birth of our universe and why it grew to look the way it does now. When scientists first started playing with magnets and wires and thinking about electrons, they had no idea how technology would evolve in the next 100 years. The scientists thinking about the cause of neutron stars and strange matter today may be setting up humans for a future beyond our wildest imaginations. Or maybe not. Time will tell.